Now let's see the question number 13. Now, one of the easiest questions in terms of the concept involved, it's based on the basic concept of units digit of a number raised to a power. So let us see how to answer this question. P is a positive integer, which means a natural number. And it seems the units digit of P cube is 4. Now, since P cube ends with 4, it means P cube is an even number. Now, if P cube is even, we know that P must also be an even number. So, P must end with either 0 or 2 or 4 or 6 or 8. But the problem is, if P is ending with 0, then P cube will also end with 0. But P cube is ending with 4. So P cannot end with 0. If P is ending with 2, then P cube will end with 8. So not. If P is ending with 4, P cube will end with 4. If P is ending with 6, P cube will end with 6. And if P is ending with 8, P cube will end with 2. So from here, I can confidently determine that P is the number that ends with 4. Hence, P plus 3 will be a number that ends with 7. And if a number is ending with 7, then the cube of that number will end with 7 cube, that is 343. So the last digit is 3. Hence, the right answer is option A. Let's see the question number 14. If a 3-digit number is chosen at random, what is the probability that it is divisible neither by 3 nor by 4? Now, how many 3-digit numbers are there? Starting from 100 till 999, we have 900 3-digit numbers. Out of these, I want to know how many are divisible neither by 3 nor by 4. So which means I need to find the number of 3-digit numbers that are divisible by 3 or 4 and remove them from the total. Now, multiples of 3. Multiples of 3 from 100 to 900. Now, the largest multiple, 100 to 999. So 999 is the largest 3-digit multiple of 3. And the smallest 3-digit multiple of 3 is 102. So the number of 3-digit multiples of 3 we have is 999 minus 102 by 3 plus 1. Now, which is equal to 300. Similarly, if we want to find multiples of 4 from 100 to 999, the largest 3-digit multiple of 4 is 996. The smallest 3-digit multiple of 4 is 100. So the total number of multiples of 4 we will have is 996 minus 100 by 4 plus 1, which is equal to 225. Now we need to find how many numbers are both multiples of 3 and 4. Now multiples of 3 and 4, that is multiples of 12 from 100 to 999 is the largest multiple of 12 is 996 minus the smallest multiple of 12 is 108 divided by 12 plus 1, which is equal to 75. Hence, 3-digit numbers which are multiples of either 3 or 4 is equal to 300 plus 225 minus 75, which is equal to 450. So out of 900 numbers, if 450 numbers are either divisible by 3 or divisible by 4, then the remaining 450 numbers are neither divisible by 3 nor by 4. So hence the required probability is 450 by 900, which is equal to 1 by 2. Answer option D. Now let's look at question number 15. This probably I would consider as one of the toughest questions in IPMAT Indore Quant section. So let us see how to answer this. Now, let x in square brackets denote the greatest integer not exceeding x, which is the standard definition of greater integer function, which is defined as greatest integer less than or equal to x. And in this expression, we have x within flower brackets that is equal to x minus greater integer x. So x minus greater integer x, which is x in flower brackets, let us define it as fractional x. Now, if you understand the concept of greater integer function, you know that x minus greater integer x, which is equal to the fractional value of x, starts from 0 and is less than 1. X minus greater integer x will be either 0 or a value less than 1. Now, keeping this in mind, let us look at the expression given. Also, from this, I can write x as greater integer x plus fractional x. It is given that 2 into greater integer x is equal to x plus n into fractional x. Now, if I substitute x as greater integer x plus fractional x plus n into fractional x. Now, if I bring the greater integer x to the left side, so 2 into greater integer x minus a greater integer x becomes greater integer x alone. And on the right side, if I take fractional x common, I get n plus 1 into fractional x. Now, we are to find the sum of all possible values of x for different values of n, where n is a natural number. So let us see what are the different values of x we will get for different values of n. Now, since n is a natural number, let me start by considering n is equal to 1. Then the greater integer x becomes equal to now 2 into fractional x. Now, this is a very important point to understand. Greater integer x is always an integer. So, if 2 into fractional x must be an integer, it is possible only when fractional x is equal to 1 by 2. So that 2 into 1 by 2 will result in an integer. And remember, the fractional x always lie between 0 to 1. Hence, the value between 0 to 1 that will make 2 into fractional x as an integer is only 1 by 2. So from here, I determine that fractional x is equal to 1 by 2. Hence, the value of x that is possible here, we know x is nothing but greater integer x plus fractional x, and greater integer x is 2 into fractional x plus fractional x, that is 3 into fractional x, which is 3 into 1 by 2, 3 by 2. Now, when I substitute n is equal to 1, I will get 3 by 2 in option C, and option D is also given as 3 by 2, which means I am able to eliminate only two options. So let me take one more value of n and see if it helps me to eliminate one of the remaining answer choices. Now, if I take n is equal to 2, we get integral x is equal to 2 plus 1, 3 into fractional x. Now, for 3 into fractional x to be an integer, fractional x must be such that 3 into fractional x must be an integer. So the value of fraction x must be equal to 1 by 3 or 2 by 3. Because fractional x again lies between 0 and 1. Now, if I look at the possible values of x, now x is equal to greater integer x plus fractional x, which will be 4 into fractional x, which is equal to 4 into 1 by 3 or 4 into 2 by 3, which is equal to 4 by 3 or 8 by 3. So sum of all possible values of x is 4 by 3 plus 8 by 3, that is equal to 12 by 3, 4. Now, if I substitute n is equal to 2 in answer option C, we get 2 into 4 by 2, which is equal to 4. Whereas option D does not say 4. Hence, option D is ruled out and answer option C is the right answer. So ideally, this is a question which you should have skipped in the exam, or you should skip in case you come across such a question in the exam, because of the nature of the question and also the fact that it will consume good amount of time. Now let's look at this 16th question. There's an 8 by 8 chessboard. The number of ways 8 rooks can be placed on the board such that no 2 rooks are in the same row and no 2 are in the same column is. Meaning, now if I take a chessboard of 8 by 8, now, of course, this is only for your understanding. In the exam, I don't think you should draw the chessboard. You should visualize. Now, I have 8 rooks and I want to arrange them on this board in 8 places such that no 2 rooks are in the same row and no 2 rooks are in the same column. Meaning, suppose if I put the first rook somewhere here, then this entire column and this entire row cannot be used again for any other rook. Similarly, if I put, let's say, the second rook here, then this particular column and this particular row cannot be used for any other rooks. So this is what the logic is, or the condition is. Now, how do we arrange these rooks? First thing first, the first rook, rook 1, can be arranged in 8 ways in any of the 8 positions in a particular row or column. Now, once I put the first rook in a place, then that particular row and column are not available anymore, which means for the second rook, I can put it in any of the remaining 7 places, row-wise or column-wise. By same logic, rook 3 can be arranged in any of the remaining 6 places in 6 ways, so on. And rook 8 can be arranged in only the last place available, that is 1 way. Hence, the number of ways in which we can arrange these 8 rooks is 8 into 7 into 6 into so on till 1, which is short form for 8 factorial. Hence, answer option